Hey guys, this is Miss Jones. Hope you're doing well. We are going to talk about atmosphere composition. So, atmosphere is just an envelope of gases that surround the Earth. It has a mixture of nitrogen, oxygen, and other gases, such as carbon dioxide and water vapors, that surround the Earth. High above the planet, the atmosphere becomes thinner until it gradually reaches space. The atmosphere is an important part of what makes Earth livable. It blocks out some of the sun's dangerous rays from reaching Earth. It traps heat, making Earth a more comfortable temperature. And the oxygen within our atmosphere is essential for our life. So, atmosphere is very important. So the gases of the atmosphere are as follows. Nitrogen is 78%, oxygen is 21%, and other gases are 1%. Now, most people think that oxygen is the main gas of the Earth, but that's not true. Nitrogen actually is. So nitrogen is the most abundant gas in the atmosphere. It makes up 78% of the atmosphere. Oxygen is the second most abundant gas in the atmosphere. It makes up around 21%. So if you're looking at this picture and you see the difference, if you see the nitrogen, which I'm going to highlight, is the N2. You'll notice that it's more abundant in the Earth than the oxygen. So you see more nitrogen in the Earth than you do oxygen. Interesting. So, the next thing we're going to talk about is, if I can get it to move, sorry. Okay, so the next slide we're going to talk about is carbon dioxide and water. These are the other 1% of the gases. Each one of them is less than 1%. A lot of us have heard about carbon dioxide. It's given off when fossil fuels are burned. So like when you're burning coal or oil, it releases the fossil fuels. Water vapor, which some people don't realize it's a gas, but it is the reason why our air is never completely dry. So if you look at the chart here, the distribution of the water vapor, the little earth with the green and red areas, you'll see that the red areas, which is close to the equator in the middle, are the most warmest. So air closest to the equator is the most warmest. As it goes out, you'll notice at the top, cold air doesn't have much water vapor, so it just is at the top of the North Pole and the South Pole. So the other gases, which are carbon dioxide and water vapors, are our main two other gases, but there are other ones that are called trace gases, like argon and methane and nitrous oxide and helium and so forth. They make up about 1% of the atmosphere with the carbon dioxide and water vapor. So as you'll notice, they're not a lot of gases such as carbon dioxide and water vapor and the other ones as there are nitrogen and oxygen. So particles. I didn't know, you may not realize that floating around the air are solid pieces of particles, which are liquids and solid pieces floating around. I don't know if you've ever kind of looked at it, but sometimes you can think you can see like something in the air. Well, that's because there are particles in the air. There's really no such thing as pure air without particles, except in a controlled laboratory. So in a scientific laboratory, you could have air that is filtered out of the particles. So, one of the ways to remember the gases that are a part of the atmosphere is never offend crazy women. So, if you see this lady, she's running after this scientist. I'm going to say it's a scientist. But never is the N for nitrogen, offend, which is the O for oxygen, crazy, C for carbon dioxide, and women for water vapor. So never offend a crazy woman. Now, the importance of the atmosphere is very important to us. So it makes conditions on Earth suitable for the living things. It contains oxygen, which is something we need to survive. It traps energy from the sun to keep the water in the form of liquid, which is needed for life. And then it also helps protect us from harmful radiation. So the atmosphere is the protective layer of gases that shelters all of our life on Earth, keeping temperatures within a relatively small range and blocking out the harmful rays of sunlight. So without the atmosphere, we would probably burn up or not be able to breathe. Okay, so now we're going to talk about the layers of the atmosphere. The closest one to us is called the troposphere. Then comes the stratosphere, then the mesosphere, then the thermosphere, and then the exosphere. So now we're going to talk about the different ones, and you'll notice that with each one, it's based, how we know which ones are which is based on the temperature changes of these layers. So you can remember the layers with another acronym, which is the smart man tricks everybody. So troposphere, stratosphere, mesosphere, thermosphere, and exosphere is the smart man tricks everybody. So let's talk about the troposphere, which is tropo, which means turning and changing. It's always turning and changing. So it's always moving and shaking, is what I like to say. So we live in the troposphere. Living at the surface of the earth, we are usually only aware of the events happening in the lowest layer, which is the troposphere. This is where all the weather occurs. The base of this layer is warmer than its top because the air is heated by the surface of the earth, which absorbs the sun's energy. So this is the lowest layer of the atmosphere. All the weather occurs here, and planes fly in this layer. Temperature gets cooler, and as you go higher in the troposphere, and it has the highest amount of air pressure because there are more air molecules. So it goes from hot to cold. The next layer is the stratosphere, or strato, which means spread out. This contains the ozone layer, which protects us from the harmful UV rays that you're always hearing about. And as you go higher in the stratosphere, it gets warmer. So above the troposphere lies the stratosphere, where jet airplanes fly. Temperatures increase with altitude because of increasing amounts of ozone. The ozone layer within the stratosphere absorbs harmful ultraviolet rays of sunlight. So it protects us from the sun's harmful light. Okay? So the next one is the mesosphere. Meso, which equals the middle. So this is the middle layer. This protects us from meteors. They break apart in this layer, giving off a look of shooting stars. So when you see a shooting star at night, it's actually a meteor that has broken apart and is trying to come to the Earth, but it won't reach us because of the mesosphere. It has the coolest temperatures. It gets cooler as you go higher in this layer. So it extends upward above the stratosphere. The temperatures decrease. The coldest parts of our atmosphere are located in this layer and can reach a negative 90 Celsius. Also, the meteors and the rock fragments, remember, burn up in this. So that is where they look like shooting stars. The thermosphere, which is thermo, which means heat, is the hottest layer. It's the fourth layer of the Earth's atmosphere. It has a sub-layer called the ionosphere that is ionized by radiation. This means that the ions in this layer bounce back waves, like radio waves, back to the Earth's surface. It increases in temperature as you get higher in the temperature. So the air is very thin in this layer. There are fewer air molecules. The thermosphere is very sensitive to solar activity and can heat up to 1500 degrees Celsius or higher when the sun is active, making an aurora that lights up the night sky. Astronauts orbiting Earth in the space station or space shuttle spend their time in this layer. So that's pretty neat. So the exosphere, which is the outer, exo means outer, is the outermost layer that fades into space. It can be considered the outer part of the thermosphere. Satellites can orbit in this layer. So this is the, This is the, Sorry about that, guys. This is the upper layer where atoms and molecules escape into space. So that's pretty neat, isn't it? Okay, so remember, troposphere goes from hot to cold. Stratosphere goes from cold to hot. Mesosphere goes from hot to cold. Thermosphere goes from cold to hot. And then the atmosphere is just out there. So, in between all the layers of each layer of the atmosphere, there are boundaries to separate them called a pause. So it's basically the same name, tropopause, stratusfalls, mesopause, thermopause, exopause. So they all use these areas to separate the layers of the atmosphere. So if you notice from this picture, which is a pretty neat picture, you see each layer shows, like the troposphere is where we live, where weather happens, and airplanes can fly in it. And then the stratosphere is where airplanes can fly into. The metasphere is where you have asteroids or meteors falling to the Earth. And then the thermosphere is where satellites and the shuttles can live. It also has like the northern lights, if you look over here, that makes it pretty neat. So I hope you understand all the different layers of the atmosphere. And we will talk about these when you come back into class on Monday.